Alright, welcome to another session where we're solving tutorial sheet number 4. So this tutorial sheet is basically on modulus functions, radical functions, and inequalities. So these are the questions we're going to solve. So we're solving this tutorial sheet, Abraham, Timbo suggested, and others. So basically we're going to solve all these questions. So let's start with the first question. We're told that on the same graph we are supposed to sketch the graph of y is equals to the modulus of x, and also the graph of y is equals to the modulus of 2x minus 1. So of course a typical modulus is just the same first equation, y is equals to the modulus of x. Let's say this is our graph. Alright, this is the y-axis, this is the x-axis. Now, you know that a modulus looks like a V. Now, it looks like a V because of just the nature of the modulus itself. So if we've got y is equals to the modulus of x, if we start replacing x and y values, if we start replacing x values, putting in the equation there, let's say we start with a -2, a -1, a 0, a 1, and a 2. Now in the modulus expression, all the answers that are going to be coming out there should always be positive. So in this case, if we put the modulus of -2, we're going to have a 2. The modulus of -1 will just be a 1, 0, 1, and 2. Of course, if I put -2 here, okay, let me start with the -2 there and -1 here. 1 here, 2. 1, 2. Of course, -2, 2 will be a point there. -1, 1 will be a point there. 0, 0 there. 1, 1 there. And 2 there. Then since we're saying this is just V, so this is going to be, you have to make sure that all the points are aligning, but it's going to go like that. So this is a modulus of x on the graph. So this is y is equals to the modulus of x. Another way you can graph this is you look at the value of x in the modulus is positive, so meaning x is equals to positive. Then you also look at the value of the whole function, y is equals to a positive modulus. So there the value of the whole function is also positive. In this quadrant, x is positive, y is positive. In this quadrant, x is negative, y is negative. However, in the other quadrant, here x is positive, y is negative. The opposite is true for this quadrant. Y will be positive, x will be negative. So in our case, all of them are positive, so it is in this quadrant, and it's supposed to be a V. It is very prudent for you to put it like that. You can put the V in the other side. So basically that. So that is how we solve the first graph. For the second graph, actually it's more interesting because for the second graph we have a shift in the x. So this is a shift in the x. If we had a number like maybe +4, this would have been a shift in the y. So for us to find the shift in the x, get what you have in the modulus and equate it to 0. So 2x minus 1 is equals to 0. So in this case, 2x will be equals to 1. I'm going to divide the 2 on both sides. So in this case, x will be equals to a half, or a 0.5. Alright, so that is a 0.5. It means now our graph for this other equation is going to start, instead of it starting at 0, 0, it's going to start at half. Alright, let me say half is somewhere between, okay, somewhere here. Let's say half is somewhere there. So it means this graph is going to be different. Of course, it's going to pass through that point and go in that direction. So but basically that is how you're going to draw them on the same graph. But now you're going to realize that we've cut this point for the second graph. So we're supposed to find that point, and that point is the y-intercept. on the y-intercept, x is equals to 0. So it's going to be y is equals to the modulus of 2. The modulus of 2 multiplied by 0, that is a 0. So 0 minus 1. Now the modulus of 1, the modulus of the 1, that is just a negative 1, that is just a 1. So this point here is going to be a 1. Alright, so basically that is how you're going to graph these two modulus equations on this graph. Okay, so y is equals to the modulus of x, the other one y is equals to the modulus of 2x minus 1. So basically that is how you graph these ones. Then the second one is asking us to solve this equation. Alright, so solving modulus equations, of course you can square both sides and you solve. So I'm going to have, you have the modulus of x is equals to the modulus of 2x minus 1. Alright, so to remove the absolute bars, square both sides. So I'm going to have x squared is equals to 2x minus 1, then you square this. Of course I'm going to have x squared is equals to, I expand this, the quicker way it is going to be, I square this part, 2x, so that will be 4x squared, then I square the negative 1, it will be positive 1. Then for us to find what you were supposed to put on the middle, we're going to say 2 multiplied by 2x, that is 4x. 4x multiplied by negative 1, we're going to have a negative 4x. So here we're going to have a negative 4x. So basically that, then you solve this expression. So I'm going to take the x squared to the other side. I'm going to have 0 is equals to 4x squared plus x squared minus 4x plus a 1. So 0 will be equals to, this will be, is it? Okay. So when I took the x squared to the other side, it's supposed to be negative x. So this is negative x squared. Of course, it's going to give us 3x squared minus what? Minus 4x and plus a 1. Then I'm going to come up with the product, the sum, and the factor method. The factors, of course, two numbers, when we multiply them they'll give us 3, but when we add them they'll give us a negative 4. Negative 3 and negative 1 will be able to achieve that. Then we just replace where we have negative 4. So we're going to have 0 is equals to 3x squared minus 3x minus x plus a 1. Then you solve. Okay, 0 will be equals to, this side I'm going to factorize out the 3. I think I can even factorize the 3x actually. 3x, I'm going to remain with x minus 1. This side, when I factorize out the negative, I'm going to have x minus 1 too. This will be equals to, actually it's already equals to 0. Then you get 3x minus 1. Then you get either of them, x minus 1, you can get one of them. So this is what we have, this is equals to 0. Then you equate each of these individual equations to be equals to 0. Of course, we've got 3x minus 1 is equals to 0, so 3x will be equals to 1. Therefore, x in this case is equals to 1 over 3. Then the other one is x minus 1 is equals to 0, so x is equals to 1. Then for modulus functions, you are always supposed to test your answers if they are correct. So if they are valid or not, how do you do that? So in your sum equation, replace these answers that you found. So the first one found 1 over 3, so the modulus of 1 over 3 is equals to the modulus of 2, 1 over 3 minus 1. Of course, the modulus of 1 over 3 is just 1 over 3. This will be equals to 2 multiplied by 1 over 3, that would be 2, 1 over 3 minus 1. Okay, this becomes a fraction. So 3 into 3 is 1, 3 multiplied by 2, that is 3 into 3 is 1, 1 multiplied by 2, that is a 2, minus that is 3, 3 multiplied by 1, that is a 3. We're finding the modulus of that. Here we already have 1 over 3. Now 2 minus 3, that is a 1. Now it's a negative 1, negative 1 over 3. Now the modulus of the negative 1 over 3, we said is always a positive. You can't have a negative outside coming from a modulus. So basically the 1 over 3 is valid. What about 1? If we put 1 here, the modulus of 1 is a 1. If we put 1 here, 2 multiplied by 1, that is a 2. A 2 minus this 1, it will just be a 1. So both of them are valid. We come to question number 2. We are told that on the same diagram we are supposed to sketch this quadratic and this modulus. Then afterward we are supposed to solve this equation. Alright, so basically this is the equation that we have. I'm going to write it in the standard way. Of course, y is equals to negative x squared plus 2x plus 24. Now I don't want the negative in front. I'm going to multiply everything by a negative. Therefore it's going to be x squared minus 2x minus 24. Then I'm not really concentrated on finding the turning point. Of course you can find the turning point. X is equals to a negative b over 2a. Yeah, you can go that route, or you can use completing the square, but I just want to find where we're going to cut our graph. So I'm going to use product, the sum, and the factor method. I just want to see how the graphs are going to behave. Of course the product in this case is negative 24, the sum, it is negative 2. Then the factors, the two numbers, when we multiply them they'll give us negative 24, but when we add such numbers they'll give us a negative 2, negative 6, and a 4. Alright, so in this case I'm going to have x squared minus 6x plus 4x minus 24. Then you solve this. I'm going to factorize out the x. I'm going to have x plus x plus what? Plus 6. Then I'm going to come on the other side. I'm going to factorize out the 4. I'm going to remain with x. Actually I've made a mistake this side. It is x minus 6. I'm going to factorize out the 4. I'm going to have x minus 6 as well on the other side. So this side I've got x plus 4. Alright, factorize only the 4 here. X plus 4, then the other one is going to be x minus 6. Alright, this whole expression goes to 0, so one value of x is going to be a negative 4, the other value of x is going to be a 6. Alright, so that is where we're cutting our graph. Alright, so if we draw, we put our plane like that. Alright, so negative, let's say negative 4 is here, negative, we've got positive 6 there. Then where are we going to have the y-intercept? On the y-intercept, get the expression. Then on the y-intercept, x is equals to 0. So this would be 0, this would be 0. We're just going to remain with a 24. So a 24 is, let's say, somewhere there. So we're going to realize that our graph for this one, even if we haven't found a turning point, it's going to pass through this point. We're going to have a certain turning point and it goes through 6. Let me put 6 a bit on the other side. Let's say our 6 is this side. Alright, then it goes like that, passes through that point, and it goes like that. Of course, you're going to have a certain turning point which you're supposed to find. And then How do we now find the other one, the other graph? So for the other one, we have a shift in the x. So get what you have in the bracket. 5x minus 4 is equals to 0. So in this case, 5x will be equals to 4. Then I divide by 5 on both sides. X will be equals to 5 into 4, that is 5 into 40, that is 8, 0.8. So it means our graph is supposed to start at 0.8 for x. So let's say 0.8 is somewhere there. In this case, look at the value of the whole function is positive, and the value of x as well in the modulus is positive. So we're going to where x is positive and y is positive. So of course, you know that it is in this quadrant, but we're starting here, so it's going to go there. So it means another one is going to go on the other side because it's a modulus function. Now I'm able to see that we are cutting that point at this point. So we're supposed to also find that point. The way we find that point, we know that on the y-intercept, x is equals to 0. So if I put a 0 here where there is x, if I multiply by 0, it's just a 0. Then we're going to be forced to find the modulus of the negative 4. The modulus of negative 4 is just a 4. So this point here is a 4. So basically, this is how our graphs are going to look on this same plane. Alright, then we solve this equation that we've been given. So we've got 24 plus 2x minus x squared is equals to this modulus function. Now, since it's the modulus, the way we remove this modulus, you can either put the positive or the minus part of it. So I'm going to first start with the positive part of it. Then the same equation, this time around I'm going to put a negative. So that's how you can remove the modulus, or you square both sides. But I'm going to have a very, very big number, which I don't want, where I square this side and I also square this part. I don't want to, I'm avoiding the power 4. So basically, even like this is even the quicker way. So in this case, then what are you going to do? It's just a matter of us putting the like terms together. So I've got a 5x when it comes to the other side. I'm going to have, okay, let me put 24 here. I've got a negative 4. When it comes on the other side, it's going to be positive 4. Then I've got plus 2x. When I bring the 5 x to the other side, it's going to be negative 5x. Then I've got negative x squared. This is equals to 0. Of course, 24 plus 4, that is 28. This is going to give me negative, we've got negative 5x and 2x. That will give us a negative 3x. Then we have a negative x squared is equals to 0. Alright, this is what we have. I'm going to rearrange it. I'm going to say negative x squared minus 3x plus 28 is equals to 0. Then let me try to see if the product and the sum and the factor method is going to work. So the product, in this case, negative 1 and 28, that will give us a negative 28. Then the sum is negative 3. Then two numbers, when we add them, negative 3. When we multiply them, negative 28. So we have a negative 7 and a 4. Then we just replace where we have 3x there. So I'm going to have negative x squared, negative 7x plus 4x plus 28. Okay, this way expression is goes to 0. Then what do? I'm supposed to factorize. I'm going to factorize the negative x. I'm going to remain with x minus 7. Actually, x plus 7. Because of the negative we put there. So x plus 7, then plus, on the other side, when I factorize out the 4, I'm going to remain with x plus 7. This is goes to 0. So in this case, we're going to have x plus 7. Again, we're going to have 4 minus x is equals to 0. So the values of x for this first equation, x will be equals to negative 7. Another value of x will be equals to 4. So basically that is how we solve this one. Then for the second part, you can also do the same, but what you're just supposed to do is that first make sure that you distribute the negative. I'm going to have negative 5x plus a 4. Then you take these ones to the other side and you solve like we are just from solving this one. We come to question number 3. We are taught to sketch each of the following modulus functions. So of course, if I'm going to say this is my y-axis and this is my x-axis. So for the first part, always look for these two things, x and y, the values of these, so that we know the quadrant in which the modulus is going to. So in this case, look at the x in the modulus is positive. Then look at the value of the whole function. You're able to see that because of this negative, the value of the whole function is negative. So we're going where x is positive and y is negative. So you know that it is in this quadrant here, x is positive, y is negative. So our graph is supposed to go in that quadrant. But however, we've got shifts here. We don't have a shift in the x, but we have a shift in the y. 3. We've shifted our graph 3 units. So that's the shift in the y. I can put a 3 there. So automatically now we're able to graph this. So this, of course, is going in this quadrant. But since it's supposed to be a v, so in this case, it's going. The other part is going to go there. That is how our graph looks like. However, we've cut these 2 points, so we're supposed to find those points. This one, we're supposed to find this point, this one, and this one. Those are the x-intercepts. On the x-intercept, y is equals to 0. So what are those points then? So 0 will be equals to negative the modulus of x plus 3. So I'm going to take the 3 to the other side. I'm going to have negative 3 is equals to negative the modulus of x. For me to remain with the modulus of x, I'm going to divide by negative on both sides. So these are going to cancel. So 3 will be equals to the modulus of x. Then how do we remove the modulus? Like we've said, x in this case will be 3. The other value of x will be equals to a negative 3. So in this case, this will be negative 3 and the other one will be positive 3. These are the x-intercepts. So that is how you graph the first one. Alright, the modulus of a polynomial function for b. So f of x is equals to the modulus of x to the power 3. Now of course you can come up with a table of values for x and y to see what you're going to be having once you replace there. Let's start with negative numbers, negative 2, negative 1, 0, 1 and 2, and replace in this equation. If we say negative 2, the modulus of negative 2 to the power 3, of course I'm going to have negative 8. Now the modulus of negative 8, it is just 8. So here I'm going to put 8. What if we put negative 1 now? Okay, negative 1 to the power 3, that is just a negative 1. Now the modulus of a negative 1, it is a 1. So I'm going to put a 1 there. The modulus of 0 is 0, the modulus of 1 is 1, the modulus of 2 is 8. So able to see we can't have a value of y which is negative once you put in the modulus. So if that is what we have, we're just supposed to plot and we see how our graph is going to behave. So of course this is the y-axis, this is the x-axis. Then we just put our figures. Let's say this is negative 2, negative 1, 1, 1, 2. For y values, I'm just going to put 1 and 8 because those are the prominent answers that we've gotten from there. Alright, so let me just put an 8 and a bit on top. Then you just graph your points. So we've got negative 2, 8, let's say somewhere there. Negative 1, 1 is there, 0, 0 is here, 1, 1 is there, and 8, 2, 8 is there. So of course a graph that looks like this and goes like that. Alright, and that is how it is going to look like. Now look at the value of the whole function. There is no negative, so y is positive, so it's in this direction. X is also positive, it's in this quadrant. So basically that is how we graph B. Then for C, it is the same thing, but we're just supposed to first expand what we have there in the brackets. Alright, so we've got x plus 1. This is multiplying with 2 minus x. Then we have a modulus outside. So I'm going to ignore the modulus for now. I'm just going to solve it as if it's just a normal quadratic. So in this case, when I expand x multiplied by 2, that will give me 2x. X multiplied by negative x, I'm going to have negative x squared. Then 1, when it multiplies with everything, I'm going to have 2 minus x. Then from there, of course, I'm supposed to add the like terms. I've got 2x and a negative x. Okay, so I'm going to just write it in the normal way, negative x squared. Now 2x minus x, that will give me a positive x. So positive x plus a 2. Alright, positive x plus a 2. If this is what we have, now I'm going to solve this equation, negative x squared plus x plus 2, just like a normal when you're using completing the square. Now if I'm using completing the square, let me factorize out the negative. I'm going to remain with x squared minus x minus 2. Alright, if I've done that, now I'm supposed to find the half of the coefficient of x, that which is negative 1. The half of negative 1, you know that if I multiply this by half, I'm just going to have negative half. Then of course I'm supposed to square this later on. Alright, so in this case, what are we going to have? Negative. Of course, since x is square, I'm going to get one of the squares of x minus the half that I was talking about to square this. So the other part is going to be half as well. So it's going to be 1 over. Now if I square half, if I square negative half, I'm going to have 1 over 4. Right, but the negative is going to remain. So in this case, I'm going to have 1 over 4 here. Then don't forget to have a minus 2 there. Basically this. Then we're always carrying our negative outside. Then you have x minus half, this is squared. Then you solve this fraction. So negative 1 over 4 minus 2. So I'm going to have 4 there. That is 4 into 4 is 1, that is negative 1. 1 into 4 is 4, 4 multiplied by negative 2, that is negative 8. Negative 8, that will give us negative 9 over 4. Alright, so this expression here is negative 9 over 4. Then don't forget to have a negative that is multiplying with everything that is in the bracket. So this is already in a bracket, so the negative is just going to be outside. So in this case, what then are we going to have? We're going to have negative x minus half, this is squared, plus 9 over 4. Right, because this negative is also going to multiply with the negative there. So this is what we have as for now as our final equation. From our equation, we're supposed to find the turning point. You know that in completing the square, we always want to have this form, where your turning point is equals to negative p comma q. Now in this case we have a negative half and we are saying negative p, so the value of x should just be a half. Then the value of p, you get it the way it is 9 over 4. 9 over 4. So that is going to be the turning point. Then what do we now do? It's just to now then sketch our graph. Of course, the y-intercept, you just get the equation, and where there is x, you put 0. Let's say this is our graph. All right. Okay, we've got what are the where are we cutting the x-axis? All right, so we've already been, the goodness with this question, we've already been given a well factorized equation. So of course these ones are already factorized, so just get them. X plus 1 is equals to 0. X, we've got 2 minus x is equals to 0. Then find the values of x. So for the first one, x is equals to -1. The other one, x will be equals to a 2. Alright, so those are the points. So -1, we can put -1 here, we can put a 2 there. So that's where we're cutting the x-axis. To find us the y-axis, wherever there is x, put 0. So put 0 here, we put 0 there. So we're going to have 1 multiplied by 2, which will give us a 2. So I can put a 2 somewhere there. Alright. So this tells you something. Of course, our graph is going to go. It's going to go nicely like this. It's going to go. Of course, our graph is going to go like this, but it's going to rebound and go like that, and it goes like this, and it goes like this. So that is going to be our graph. However, of course, we have a turning point. Our turning point here is half, comma, let's say 9/4 is somewhere there. Alright, 9/4 is somewhere there. Initially, our graph was supposed to go down. If I'm going to wrap that part. Alright. Initially, our graph was supposed to go down just like any other quadratic, but because for modulus you are supposed to have positive numbers, so in this case it's going to be flipped in the other direction like that. That's what we're talking about. Yes, so basically that, then you go like that. So they say this is a 2 we found, and then here that is the turning point. So that will be the modulus. And this is how we also solve the other one. Just you solve using completing the square, graph it, but where it extends down there, you have to flip it on the other side. So that is how we solve this modulus. We come to question number 4. So we are solving equations 2x minus 5 is equals to, of course you can get the positive part and the negative part, or you square both of them, but I don't want to square so that I have bigger numbers. I'm just going to equate one of the equation to be 7, the other one 2x minus 5 will be equals to -7. Then I solve these two equations. So I'm going to have 2x is equals to 7. I take the -5 to the other side, it's going to be +5. So 2x is equals to 12. So in this case x will be equals to 6. I come to the other side, I also do the same. 2x is equals to -7 plus 5. So 2x is equals to -2. So the value of x here is going to be a -1. Then you test your answers to see if they are correct. You test your answers to see if they are correct. So you try. So if I've got 2, I start with 6 minus 5. Is it really equals to 7? So 2 multiplied by 6, that is a 12, minus 5 is equals to 7. So 7 is equals to 7. So 6 is a valid solution. We come to -1. You also try the modulus of -2 minus 5 is equals to 7. This will give us -7. The modulus of -7 is 7. So 1 is also valid. So basically those are the solutions for A. So for all questions on modulus and radicals, you are supposed to test your solutions to see if they are valid. Then we come to B. Of course, you can square both of them, but I'm not going to go for that route to avoid the bigger powers and numbers. So I'm just going to get my 2x plus 1. I'm going to equate one of each to be positive, 4x minus 3. The other one 2x plus 1 will be equals to, I'm going to get the negative part of my equation, my product, which is 4x minus 3. Then I solve these two equations. Whatever I'm going to get, those will be the answers. So 2x, if I take the 4 to the other side, okay, to avoid negatives, I'm going to take 2x to the other side. So I'm going to remain here with 1. I'm going to take the negative 3 to the other side. It's going to be positive 3. This will be equals to the 4x. Then I'm going to take the 2x to the other side. It's going to be negative 2x. So I'm going to have 4 this side. Then I'm going to have 4x minus 2x, that is a 2x. Then I divide by 2 on both sides. So therefore my x is equals to 2 into 2 is 1, 2 into 4, that is a 2. Alright, so one value of x is a 2. Then I come to the other equation, 2x plus 1 is equals to, I'm going to distribute the negative. I'm going to have negative 4x plus a 3. Then I'm going to have 2x plus 1. Alright, I just put the like terms together. So I'm going to take the negative 4 to the other side, negative 4x. So I'm going to have 2x plus 4x is equals to a 3 plus a 1. Then I add these ones. I'm going to have 6x is equals to a 4. Therefore now x is just going to be equals to 4 over 6. So x will be equals to then I divide a 2 into 2. Hope we've done the correct thing. 3 plus 1, that is a 4. Is it? Let me just check. When we took the 1 to the other side, it became a negative. Alright, so I was supposed to put a negative here. A 3 minus a 1, that is a 2. So we're going to have 2 over 6. 2 over 6, 2 into 2 is 1, 2 into 6, that is a 3. So basically that is the value of x. Then you test your solutions. Alright, so let's solve C. Okay, so for C we've got k minus 2 over k minus 1. This expression is goes to 3. So it's not very different from whatever we're from solving. So in this case, get what you have as k minus 2 over k minus 1. Equate the first one to be 3. Then get the other part to be k minus 2 over k minus 1. Equate it to negative 3. Then you solve these two expressions. Of course, I'm going to cross multiply for this one because it's just like a normal rational function. So I'm going to have k minus 2 is equals to 3. The 3 is multiplying with the k minus 1. So in this case, then what do I have? I'm going to have k minus 2. I have to first distribute the 3. I'm going to have 3k minus 3. Okay, so this is what I have. Then I put the like terms. I'm going to take the k to the other side. Then I'm going to take the negative 3 to the other side. So this side I'm going to have negative 2 plus a 3 will be equals to 3k minus k. So negative 2 plus a 3, that is a 1. This will be equals to 3k minus k, that is a 2k. So the value of k for this first part, it is a half when I divide by 2 on both sides. Then I come to this other question. So for this other question, it's the same thing that we're going to do. I'm literally going to equate to cross multiply. K minus 2 will be equals to Negative 3 is multiplying with k minus 1. Then I just solve this. So k minus 2 will be equals to negative 3k plus a 3. Alright, so that is what we have. Then I'm just supposed to now put the like terms together. So of course I'm going to have a k plus 3k is equals to 3. I'm going to take the negative 2 to the other side. It's going to be 5. Alright, then 4 that is 3k plus k, that is a 4k, is equals to 5. So the value of k therefore is going to be 5 over 4. So basically these are the solutions that we have for question C. Then we come to question number 5. We are taught to solve each of the following inequalities. So for inequalities, you want this part to be just a very flexible number that you can divide, or at best it should be an x because it's in between, so you don't want to have a fraction. So in this case I'm going to get the negative 2. This one is less than or equal to 5 minus 3x over 4. This is less than or equal to a half. Now for you to be able to reduce this, let's start first with multiplying everything by a 4. Alright, so when we multiply everything by a 4, I'm going to 4 multiplied by the negative 2, I'm going to have negative 8 this side. Then this expression multiplied by a 4, the 4 is going to divide. Hence we would have cancelled it out, which is what we want. Then we're going to have a 4 multiplied by a half. We're just going to have a 2 into 2 is 1, 2 into 4 it is a 2. We're going to have a 2 this side. Then we don't want this 5. We're going to subtract by 5 from all parts. So in this case, let me just do this. Then I subtract minus 5. Alright, so what are we going to have? So negative 5 and negative 8, it will give us negative 13. Then we've got negative 5 and 5, they are going to cancel. So we're going to just remain with negative 3x, which is what we want. Then 2 minus 5, that is a negative 3. Alright, now we can just divide by negative 3 throughout, so that we just remain with the x on the middle. Alright, so now every time you divide with a negative, it means your inequality symbols are going to change. So in this case, the negatives first they divide. All the negatives are going to divide. So this side are going to remain with 13 over 3. But the inequality symbol is going to change because we are dividing by a negative. So it's going to face the other direction. Now 3 divided by 3 it's just the 1. We're going to remain with x there. This other inequality is also going to change because we are dividing by negative 3. So 3 into 3, that is a 1. So that is what we have as an inequality. Alright, but for inequalities, most of the times you want to start with the smallest one. So 1 in this case is going to be like this, because you want to start with the smallest one going to the largest one. Of course, if you don't want to express it like this, you can express it in set interval notation. You're moving all the way from negative 1 included and 13 over 3 included as well. So we've used square brackets. So basically set intervals, that's what we've used. Then solving the other parts, we've got b is 2t squared minus 90 minus 5. This way expression is greater than 0. So in this case, what are we supposed to do? Okay, they've already given us a quadratic, but this is a quadratic inequality. So in this case, we're supposed to find, since it's a quadratic, we're supposed to find the roots. So t will be equals to, what is our a, what is our b, what is our c. So our a is a 2, our b is a negative 9, our c it is a negative 5. Okay, so negative b, positive or minus. So negative b b is negative 9. So in this case, we're going to have just 9. Positive or minus the square root of 9 squared, that is 81, minus 4 AC. A is 2, C is negative 5. 4 multiplied by 2, that is 8. 8 multiplied by 5, that is a 40. Then we have negatives there. We're just going to have a positive 40. Positive 40. 81 plus 40, that is 111. That's 121. 121, the square root of 121, it is an 11. So I'm going to have 11 there over 2a. Now a is a 2, so 2 multiplied by 2, that is a 4. So the values of t then is going to be, the first one we are adding 9 plus 11, that is a 20, divided by 4, we're going to have a 5. Another value is 9 minus 11, so t 9 minus 11, that is a negative 2 over 4. So another value of t, it is a negative half, because 2 into 2 is 1, 2 into 4, it is a 2. So these are the two values of y that we have. So then you just demarcate, of course, one value of t. T in this case, looking at the symbol, in this case t is equals to if we're going to start with the one that we have 5, t in this case, the symbol is facing in this direction, so t will be greater than 5. But on the other side, since we have a negative, t is going to face on the other direction, negative half, because there's a negative. Alright, so because of this scenario that we now have, therefore the inequality in terms of expressing it in set interval notation, the smallest one is this part, and t in this case is less than. So we're moving all the way from negative infinity to this same number, negative half, then we union, then 5 all the way to positive infinity, because t is greater than 5. So basically that is how we solve B. We come to C. So these are different versions of inequalities. So able to see that this is a normal inequality. This is in a quadratic equation, but in form of inequality. This, of course, it can be a polynomial in some instances. This is a rational inequality. This is also a rational inequality. So it just tells you that inequalities can apply in almost any topic. Under sets we have inequalities. So basically you have to be very strong on this topic. So let's start with this one. Of course, they've already expanded the expression for us. They've already factorized the polynomial. So what do we now do? We just get these ones and find the critical points. So x minus 3, you equate it to 0, you find the value of x. So this x will be equals to a 3. Then you get the other equation, 3x plus 2, you equate it to 0. So in this case, what will be x? X will be equals to, when the 2 goes to the other side, it will be negative 2 divided by 3. Then we get to the other one, x plus 4. We equate it to 0. So x will be equals to negative 4. Alright, so that is what we have. So I'm going to demarcate my signs. Of course, this part, we've got 4 equations. We've got 3 equations actually. Alright, so we've got three critical points. Okay, so we've got x minus 3, we've got 3x plus 2, we've got x plus 4. Then the values that we have, we've got negative 4 and negative 2 over 3. The smallest one, negative 4, then negative 2 over 3, and then a 3. So that is what we have, and these ones are multiplying, so it means we're finding the product of signs. Alright, so let's start with the first equation, x minus 3. X minus 3 gave us 3 as an answer. So if it gave us 3 as an answer, if we get any number that is greater than 3 and we put in this equation, let's say we put a 4 there, 4 minus 3, which is a positive answer that we're going to get, so this is positive. Then if you get a number that is less than 3, let's say a negative 2, or let's say just a 2. If you say 2 minus 3, that will give us a negative 1. So here it's going to be a negative, negative, and negative. We come to the second equation. We've got 3x plus 2. This one gave us negative 2 over 3. If you get a number that is greater than 2 over 3, negative 2 over 3, let's say 0. If you put a 0 here, we're just going to have a positive answer. So positive, positive. But if you get a number that is less than negative 2 over 3, let's say a negative 1. If you put a negative 1 there, we're going to have a negative answer. So negative, negative. Alright, then for x plus 4, what it gave us a negative 4. So if you get any number that is greater than negative 4, let's say a negative 3. Negative 3 plus 4, that will give me a positive number, a positive answer. So here is positive, positive, and positive. But if you get a number that is less than 4, let's say a negative 5, we're going to have a negative answer there. Then we find the demarcation of signs. Negative, negative, and negative, when we multiply them, I'm just going to end up with a negative here. Negative, a negative, and a positive, I'm going to have a positive here. This will give me a negative, this will give me a positive. Alright, so this is what we have. Then we're supposed to now look at how then are we going to demarcate our signs. We go back to our inequality. So our inequality is saying this way expression is less than 0. Since it's less than 0, numbers that are less than 0 are negative numbers. So from our solution set, we're getting only the negative regions. That would be the solution set. Now the inequality is not including anything, so it means we're going to use open brackets. So the solution set then will be, you can express it in set interval notation. Of course, going this side is negative infinity, going this side is positive infinity. So in this case, we're going to start from negative infinity all the way to where our 4 there is. So negative 4 is not included, union. Then the other part, it is negative 2 over 3 all the way to 3. Then we end there. So that will be the solution for this part. So that is how we solve C. Alright, so these two equations, they are the same. They are the same. So basically what you're just supposed to do, because these are inequalities, you are not supposed to cross multiply. So just take the 2 to the other side and also take the other one to the other side and just solve like any normal equation. So you can solve this one. It's very simple. I'm going to start with this one. Alright, okay, let me start with the first one, but I'm not going to finish it. I'm going to take the 2 to the other side to be minus 2. Then this will be greater than or equal to 0. Then find your common denominator. In this case, we're going to have what, a minus 5 as a common denominator. Then when we divide this into that 1, so I'm going to have a minus 1 on top, minus, then 1. Okay, so I'm going to have a minus 2, which is multiplying with a minus 5. Then you solve what you have on top, like any other equation. Alright, so we've got a minus 1 minus 2a plus a 10 over a minus 5. This is greater than or equal to, this is less than or equal to 0. Then you solve what you have on top. We've got 10 minus 1, that is a 9. So I'm going to have 9. Then a minus 2a, that is just going to give me minus a. Alright, then down we just have a minus 5. This is equals to, or this is less than or equal to 0. Then you come up with your critical points. Of course, let's say one of the critical points, 9 minus a is equals to 0. So 9, okay, let's say a in this case will be equals to a 9. Then another value of a will be what? A in this case will be equals to a 5. Alright, so 5, I'm going to start with the smallest one, 5 and 9. Then you write your equations. We have 9 minus a, the other one it is a minus 5, and these ones are dividing, so you're supposed to divide your signs, and you just do the same. So we're going to do, in this case, if you get this 9 minus a gave us a 9. If you get a number that's greater than 9, we put here, let's say a 10. In this case, we're going to have a negative number. But if you get any number that is less than 9, we say an 8 there. We're going to have a positive number. So positive, positive. We come for 5. For 5, if we put any number that is greater than 5 there, what are we going to get? Let's say we put a 6 there. We're going to have a positive, positive. But if we get anything less, we're going to have a negative. Now that we got this, then what do? We divide our signs. This is going to be negative, this is going to be positive, this is going to be negative. Then the question then will be, we're going to go to look at our inequality. So our inequality there, it is greater than, or actually this expression is less than or equal to 2. So because of that, you're able to see that then this, we're just looking for this expression is greater than or equal to 2. But if we come back to our equation here, we are saying this expression should be, this expression should be less than or equal to 0. So because it should be less than or equal to 0, after we made it an equation, it means we're getting numbers that are less than or equal to 0, which are negative numbers. So in this case, you only want this region where we have negatives and that region going in this direction. So what then will be your solution? Of course, you're moving all the way from negative infinity to 5, negative infinity to 5, union, you're moving 5 to positive infinity. So basically those will be our answers. But now here's something very tricky here. We are saying we're moving from negative infinity to 5. Now I'm not including 5. The reason is very simple, because if we included 5 here, if we put where there's a here, if we put 5, we're going to have 5 minus 5 on the denominator, which is going to make the function defined. That's why I'm excluding 5 as well. Union. However, 9 can be included, it's fine. Okay, because of the inequality symbol, 9 is fine, it can be included. So 9 and all the way to positive infinity. So that is just the difference. Always also look at the denominator, because you know rational functions, if the denominator is 0, it becomes undefined. So division by 0 is not allowed. So for the second one, it is also the same thing. Take this one to the other side and solve and demarcate your signs. So basically that is how you solve that part. So let's come to question number 6. We're told to solve each of the following inequalities. Okay, not very different from all the inequalities we're from solving. So 6x minus 11. Alright, then we've got that inequality symbol. It's less than 2. Alright, so you know that one of the answers, of course, one of the answers should be negative, the other one should be positive. So this can either be this is equals to 2 the way it is, or the other expression, when we remove the modulus 6x minus 11, now the symbol is going to go on the other side and we're going to have a negative because we've changed the sign. So the inequality symbol also changes. So because of that, it means 6x minus 11 is going to be between negative 2 and 2. So I can write the expression as negative 2. Then I put my 6x minus 11 on the middle. This is equals to 2. That would be the inequality. But now here we just want to have x. So what do? You do like we did the first question on inequalities. We're going to add 11 on all sides. So negative 2 plus 11, that is going to give me a 9. Then when I add this by 11, the 11s are going to cancel. I'm going to remain with 6x. Then the 2 plus 11 on the far end, I'm going to have the 13. To remain with my x, I'm going to divide by 6 on both sides throughout. So in this case, 3 into 9, that is a 3. 3 into 6, that is a 2. 6 into 6 is 6 into 6, that is a 1. So I'm going to remain with x there. Then 13 over 6. So basically that is my answer. However, you can also express it as 3 over 2. Then this is 13 over 6. Both of them are not included because of the inequality symbols there. They are not included. So that is how you solve that one. However, you can also equate them individually if you wanted. You can say 6x minus 11, this is equals to 2, of course. Then you solve it individually, and like that, it's still fine. You're still going to get the same range. Which we are going to do, let's do this one for b. We've got 2x plus 3. This is greater than or equal to 4. So the first one is just going to be the way it is, positive. The other one, 2x plus 3, we're going to shift the symbol is going to face on the other direction. Then the answer is going to be negative. Alright, then you just solve these two expressions. So 2x is greater than or equal to 4. The 3 is going to go on the other side. It's going to be a negative. So I'm going to have 2x is greater than or equal to that is 4 minus 3, that is a 1. So I'm going to divide by 2 on both sides. So x is greater than or equal to half. So one of the values is half. What about this other one? So we're going to have 2x is less than or equal to negative 4. The 3 goes on the other side, it becomes negative 3. So 2x is less than or equal to negative 7. So in this case, x is less than or equal to negative 7 over 2. So these are the two answers that you have. Alright, then you just now write if you want to write it in set interval notation. Of course, you're starting all the way from negative infinity to the smallest number, which is negative 7 over 2. Then you union. Now is this included? Actually, of course, this one is included because of the equal to sign there. So negative 7 over 2 included, union. The other one is also going to be included, half, all the way to positive infinity. So that is how we are going to solve the B. Then we come to C. Alright, so C is also the same thing. We've got x plus 1 over x minus 2. Mind you, I've removed the modulus. Every time you remove the modulus, you know what you're supposed to do. 1 should be positive. You solve this part. Another one, x plus 1 over x minus 2. When you remove the modulus, you know that the symbol is supposed to shift. It will face the other side and the symbol changes. Okay, so basically that. In this case, then what are you then supposed to do? Just solve these ones independently. Whatever you're going to find as the answers, that will be your answers for the equation. So then you know how we solve these ones. We don't cross multiply. These are rational inequalities. So I'm going to have x plus 1 over x minus 2. I'm going to have minus x. This is less than 0. Then you just solve it like any other rational function. The common denominator will be x minus 2. Then you divide. I'm just going to have x plus a 1. Then when the 1 divide with that, I'm going to have negative 5 x minus 2. This is equals to 0. Then you just solve. So allow me to rub this one for the first we solve this one. X plus 1 negative 5x minus actually plus 10 over x minus 2. Alright, then we add what we have on top. X minus 5x, that is negative 4x. 1 plus 10, that is an 11, plus 11 over x minus 2 greater than 0. Alright, so you know what you're supposed to do when you reach here. Demarcate your signs like we've been demarcating our signs. So find the solution for this one. Alright, so anyway, let's just solve this part as well. So of course the first value of x minus 2 is equals to 0, x is equals to 2. That's one value of x. The other value of x, negative 4x plus 11 equated to 0. So in this case, I'm going to have negative 4x is equals to negative 11. Therefore, x is just going to be 11 over 4. 11 over 4, I think that is about 2 point something. Okay, so it means it's greater than the 2. Alright, so then you just demarcate your signs and you solve. So I was saying the other value of x is 11 over 4. Alright, let's say 2 is there. Let's say 4. Let's say this is 4. Alright, then the equations, we have x minus 2. The other one is negative 4x plus 11. And those ones are dividing. So we're finding the quotient. So we start with the signs. We start with this equation which gave us a 2. If you get a number that is greater than 2, we put here, let's say a 3. We're going to have positive answers. Positive here, positive. But if you get anything less, let's say a 1. 1 minus 2 is a negative. We're going to have a negative there. We come to the one for 11 over 4. So this is 11 over 4. Alright, so 11, 4 into 11, that is like a 2 point. Then 4 into 30, that is like maybe 7. Alright, okay, so basically this is what we have. Okay, so if you get any number that is greater than 2.7, let's say a 3, and we put in this equation, we're going to have a negative 12. Negative 12 plus 11, we're going to have a negative answer. So here we have a negative. If you get a number that is less than, we say even just a negative, let's say even just a negative 2. If you put a negative 2 there, we're going to have a small number. So we're going to have negative we're going to have a positive here, positive there. Then if you demarcate your signs, this, when you divide, is negative, here is positive, here is negative. Then you look at your inequality. Our inequality was saying this expression is less than 0, so we're getting the negative regions from here going this direction, from here going in that direction. So in this case, make sure that you consider this part. This is x minus 2, so you don't want a 2. You don't want it because it's going to make it undefined. So in this case, the solution for the first one, it is from all the way you're moving from negative infinity to 2. 2 should not be included because it's going to make the function undefined. Union, and then also the 11 over 4, and all the way to positive infinity. Alright, this is for the first part. Then you also do for the second part, and you unite whatever you have. Alright, so that is what we have for the first part. Then for the second part, it's x plus 1 over x minus 2. We said the sign is going to flip on the other side, then we are going to have a negative. Then now we solve this part, x plus 1 over x minus 2. The 5 comes to the other side, it's going to be plus 5. Then this is equals to 0. Alright, x plus 1, so I'm going to have plus 5, it's multiplying with x minus 2. Alright, then you solve what you have on top. X plus 1 plus 5x minus 10. Okay, over x plus 2. X minus 2 actually. Of course, when you solve what you have on top, x plus x on top, I'm going to have 6x. Then negative 10 plus 1, that is a negative 9, over x minus 2. This expression is greater than 0. So now, if we've got this, then what do? We now have all these equations that we have. So we're supposed to again demarcate the signs if we want. Alright, so I can alright, so we're going to get what we have on top and equate it to 0. So 6x minus 9 is equals to 0. So in this case, 6x will be equals to 9. We divide by 6 on both sides, so x is going to be 3 into 9, that is a 3. 3 into 6, that is a 2. Alright, then the other one, which is x minus 2, x will just be equals to a 2. So that is what we have, and we're supposed to demarcate our signs. So you draw your table. Alright, so let me put which one is smaller. 3 over 2 is smaller, so 3 over 2 here and the 2 there, and you write your equations. X minus 2, then the other one is 6x minus 9. Alright, then you start demarcating your signs. X minus 2, it is coming from 2. It gave us 2 actually. So if we get any number that's greater than 2, we put there. Let's say 3, we're going to have a positive answer, positive answer. But if you get any number that is less than if you get any number that is so this column is not there. If you get any number that is less than negative 2, let's say a 1, we're going to have a negative here and a negative there. We come to the 3 over 2. If you get any number that is greater than 3 over 2, and we put there greater than 3 over 2, 3 over 2 is like maybe 1.5. Is it? Yeah, 1.5. If you get any number that is greater than 1.5, let's say a 2, or yeah, even just a 2, If we put a 2 here, 2 multiplied by 6, that is like 12. 12 minus 9, that is a positive answer. So we're going to have positive answers in these regions. But if you get any number that is less than 1.5, let's say we put even just a 0. If we put a 0 here, what are we going to have? We're going to have a negative number, negative answer. And now we find now the solutions for our signs. These ones were what? These ones were multiplying. They were actually dividing. So in this case, I'm going to have a positive, a negative, and a positive. Then you go back to your equation. So this is the equation. So this whole expression should be greater than 0. Look at where the inequality is facing. It should be greater than 0. So we're only getting positive regions. So from here to the other side, from there to the other side. This is positive infinity, this is negative infinity. Alright, we just don't also want a 2 because it's going to make the function undefined. So for this other one, it is from negative infinity to 3 over 2. This is also not included. Union, you come to the other side, that is a 2, which is not included, and all the way to positive infinity. So basically this is what we have. So these are the things that we have. Now we're supposed to find the intersection between these two. Alright. However, if you're going to look at these regions, which one embeds the other one? That's the question you are going to ask yourself. Which one embeds the other one? So of course all of them are starting from negative infinity, and we are ending all the way to positive infinity. Now the 2 is not included. Alright, so in this case, this one, the 2 is both in these sets. Alright, and in this case we're going to say all the way to, this is 3 over 2. That is the first part, union. Alright, then we come to the other side, 11 over 4. It's the other one that is going to take course. 11 over 4 all the way to positive infinity. So because the 2 is in both sets, this part, look at this part, we've got 2 and 2 there. So in this case, and the 2 is not even included, we don't even want it. So in this case, we're getting this part and that part to make our solution. So basically that is how we solve that part. So the way we've solved C, that is how we also solve D, which has N, the same way. One is going to be negative, the other one is going to be positive. So for E we're also going to do the same, but in this case for E, just square them. We've got x plus 6. Of course you can put a negative if you want, like we did, or square them. You square this. Personally, I don't mostly like squaring because of big numbers. I usually try to avoid big numbers. Alright, so basically then how are we going to solve this? Just square like we said. So this is x squared, then 6 squared, that is a 36. Then to find what is supposed to be on the middle, 2 multiplied by x, that is 2x. That 2x multiplied by 6, I'm going to have 12x. That's what I'm going to have on this side. The other side, x squared is going to be x squared. I'm going to have x squared, 2 squared, that is a 4. Then I will find on the middle 2 multiplied by x, that is 2x. 2x multiplied by 4 by negative 2. I'm going to have negative 4x here. Then you solve these two scenarios, you put your like terms together. Now the x are going to cancel, because if I take the x to the other side, they're just going to give us zeros. So in this case, I'm going to have 12x. I bring the negative 4x to the other side, I'm going to have plus 4x. This is equals to 4 will remain. The 36, when I take it to the other side, I'm going to have a negative 36. 12x plus 4x, that is a 16x. This will be equals to, okay, equals to, in this case, what am I going to get? 4 minus 36, that is a negative 32. Then I divide by 16 on both sides. So in this case, x is equals to negative 32 divided by negative 16, that is a negative 2. Now, since here we're not really dealing with an what's this, an equation, I just have to solve it like any other equation, but there's an inequality symbol there, it's facing the other direction, so you can put it. X in this case should be less than negative 2. So if x should be less than negative 2, that is the final answer. But of course, you can also solve it the other way. You can also write it the other way, from negative infinity to negative 2. That is the same as this that we've written there. So basically, that is how you solve this one. So for the other one, it's the same thing, square on both sides. Then of course it's going to be a quadratic. Solve the quadratic, then whatever you're going to have, those will be your answers. So those are the same concepts. Then we come to question number 7. Sketch the graph of each of the following functions and determine its domain and the range. Alright, so you know that for the domain and the range, we're always just trying to look at two conditions. Number 1, you don't want a 0 as a denominator. Number 2, you don't want complex numbers, alright, where you have the square root of a negative number. These are the only two conditions that you should exclude from your solutions. So in this case, we've got f of x, and we're trying to find the domain of this radical. So in this root, we're not supposed to have a negative. So you get what you have in the root and equate it to 0. So this x minus 2 should be greater than or equal to 0. We can have a 0, it's fine. The square root of a 0 is 0, it's fine. But if we have any number that is less than 0, it's going to make the function undefined. So that is what is going to be the domain for this one. So we just solve. So x in this case will be greater than or equal to, when I take the 2 to the other side, it's going to be a 2. Alright, so x in this case should be greater than or equal to 2. So the domain for this function, we are moving from all the way from, since x is greater than or equal to 2, so 2 should be the lowest, and all the way to positive infinity. This is the domain for this function. What about the range? Because they're asking us to also find the range. Now, for the range, the lowest value of x that you can have, it is a 2. So in the equation, put a 2 and solve, so that you find the value of y. So f of x is equals to the square root of, where there's x, we are saying the lowest value of x you can have in the domain is a 2. So 2 minus a 2. So in this case, the square root of 2 minus a 2 is 0. The square root of 0 is 0. So for y, the lowest value of y that you can have, where x is starting from, it is 0. So the range for this function, it's starting from 0 and all the way to positive infinity. So basically that. We come to B. Actually, we are also sketching this graph. Alright, I've just found the domain and the range. Alright, so sketching this graph. Alright, so sketching a radical, so you can check on all our videos on how we sketch each type of function. So as a radical function, it's an arrow. Of course, you're just considering, like we always consider the other ones. Here we have a shift in the x. So when it starts here and it goes like this, it means here you started at 0, 0. There was no shift. It can go on the other side, looking at the value of the whole function and x. So let's look at the shift in x. Get what you have in the bracket equated to 0. So x minus 2 is equals to 0. So in this case, x is equals to 2. So we are literally starting from 2. Now look at the value of the whole function. It's positive, and x is also positive inside the root. So we are going to where x and y are positive, so it's in this region, and it's an arrow like that. So that is the graph. We come to B. Alright, we have a shift in the y here, and a shift also in the x. So in this case, what are we going to have? Not very different. You get the shift in the y, we said it's a -4, so put a -4 in advance. Then the shift in the x, get what you have in the root equated to 0. X plus 3 is equals to 0. X is equals to -3. So let's say -3 is somewhere here. So this is a point that we have. Then the question will then be, where are we going? So you have to look at the value of the whole function and the value of x. The value of x, you're able to see that here in the root, inside the root, x is positive. Then the value of y, the value of the whole function, the value of the whole function, it is also positive. This -4, it's a shift. So the value of the whole function, look at the whole radical function. So now it can either go like this, it can either pass through this point going like that, or it can go like this. So basically then what are you going to do? You have to find the y-intercept. On the y-intercept, x is equals to 0. So in this case, y is equals to -4 plus the square root of 0 plus 3. 0 plus 3 is a 3. So you can punch this on the calculator. I don't know what the square root of 3 is, and I don't know what -4 is. Then you add the two. Basically, it's going to give you a certain point. Maybe it's going to pass somewhere there or there, but basically that. But if you're not allowed to use a calculator, you can just draw that. Then you put -4 plus the square root of 3 as a point somewhere. So basically that's how you solve and graph that part. Then the question will be, what is the domain? You're able to see that the lowest value of x that you can have there, it is a -3. Then the highest value of the lowest value of y that you're going to have is a -4, and you're going all the way to positive infinity. So that will be the domain, and that will be the range. Alright, so for the other one, it's the same thing. We have a shift in the y and a shift in the x. So a shift in the y, we've got a 1. I can put a 1 somewhere there. Then a shift in the x, -x minus 2 equated to 0. -x is equals to 2. So in this case, divide by negative on both sides. Excuse, x will be equals to 2 divided by negative, that would be 2 divided by a negative, it would be -2. So x is equals to -2. So let me put a -2 here. Alright, so we have a point here. Then the question will then be, where are we going? Alright, so look at the value of x look at the value of x, it's negative. So we're going where x is negative, and we're going where the whole function, it is positive, y is positive. So we're going where x is negative and y is positive. So you're able to see it is in this region. That's where x is negative and y is positive. So we're going to go in this direction like that. So that is our graph. Then for D, it's the same thing. Look at the value of the whole function, look at the value of x and y. So of course, if I'm going to draw this, the value of y and now it is a negative. Look at in front, so I have a negative. The value of x, you equate what you have in the bracket, so that is 3x plus 1 is equals to 0. So 3x is equals to -1. Then you divide by 3 on both sides, so 3x or x is equals to -1 over 3. Okay, -1 over 3. So let me put -1 over 3 here. Then there's no shift in the y direction. All right, so now we're going to go into a quadrant. X, the value of x inside the root there is positive. The value of the whole function is negative. So we're going in a quadrant where y is negative and x is positive. So it is in this quadrant where x is positive, y is negative. So this is going to come and pass like that and go like that. That is going to be the graph. Now I'm supposed to find that point. That is the y-intercept. On the y-intercept, x is equals to 0. So put a 0 here. So what are you going to have? You're going to have y is equals to negative. This is 0. 0 plus 1 is a 1. The square root of a 1 is a 1. So you're just going to have a -1. So this point here is a -1. Alright. So basically that. Then what will be the domain and what will be the range? You're able to see that the highest value of x that you can have is found at that point. Same with the highest value of y. So in this case, since you're going to the negatives, so the domain and the range will start from that point. This is D. Yeah. So the domain for this function, of course, what you're going to have, the lowest being -3. Okay, apologies for that. It's the lowest because you're going all the way to positive infinity this side. So positive infinity going that side. Then we come to the range. Are you able to see that the range? That's where y also is starting from. So you're starting from 0. Alright, so you're starting from negative infinity all the way to 0, because 0 is going to be the highest point of y. Yeah. So basically this is how you solve these equations. Okay, we come to question number 8. The description of body heat loss due to convection involves the coefficient of convection Kc, which depends on wind speed according to the equation that. What is the domain? So what is the domain for this function? Alright, you know that in the root we never want to have a negative. So get that expression. That's what you are going to use to find the domain. This should be greater than or equal to 0 because you don't want a negative there. So now what do we do? So to be 4v is greater than or equal to -1. So when I divide by 4 on both sides, so therefore our v should be greater than -1 over 4. So it means the domain for this equation or for this function, since we are saying this v should be greater than this, greater than or equal to that, so this should be the starting point. Of course it's going to be included because of the inequality, so this would be -1 over 4 or quarter all the way to positive infinity. That would be the domain. Then the second question is asking us, what restrictions do nature and common sense put on v? Here v, we're talking about the speed, okay, the wind speed. Now what restrictions do nature and common sense put? So in this case, what this means is just that in real life, if you are going to look at wind speed, it is a non-negative quantity. So wind speed, of course, you can have a possibility of having something that is 0. This that's what this expression means. You can have where it's just calm, there's no speed, but negative wind doesn't make any physical sense. So what this means is that the common sense just restricts us to say our wind speed should be greater than or equal to 0. So that's what we're just talking about. Hence the domain, if you're going to look at the domain, of course you're starting from 0 all the way to some positive infinity, somewhere there. So basically that. So that's how we solve these questions. Let's solve these last questions. Solve each of the following equations. Alright, so radical equations. Okay, so you have the square root. Let's start with a 2t minus 1 is under square root plus 2 is equals to t. Alright, then you solve these equations. Of course, you're supposed to isolate the root, but for you to be able to do that, square on both sides. But before you square on both sides, I prefer you first take the 2 to the other side, so that when you're cancelling the roots, it becomes very easy. So I'm going to have the square root of 2t minus 1 is equals to t minus 2. Okay, now that I've got this, I can now square on both sides. So this side I'm going to square, and also on the other side I'm going to square. The square and the root are going to cancel this side. I'm going to have 2t minus 1 is equals to, now this is a quadratic, so I'm going to first square t squared. I'm also going to square the negative 2. I'm going to have a positive 4. Then to find us what we're supposed to put on the middle, I'm going to multiply 2 multiplied by t, that is 2t. That 2t multiplied by negative 2, I'm going to have a negative 4t. Alright, so now that we've got this, just put the like terms together and solve. So I'm going to have okay, I'm going to take everything to the other side. So I'm going to have 0 here. I'm going to have t squared minus 4t minus 2t plus 4 minus 1. Then from here I'm going to have t squared negative 4t minus 2t, that is negative 60. Then 4 minus 1 is it? Okay, so the negative 1, when it went to the other side, it's supposed to be positive. So positive 1. 4 plus 1, that is a 5. Alright, we've got this expression. We're going to look for two numbers. When we add them, they'll give us a 5, but when we add them, they'll give us a negative 6, but when we multiply them, they'll give us a 5. I think negative 1 and negative 5. So in this case, we're going to have t minus 1, t minus 5. This is equals to 0. So one value of t is going to be 1. The other value of t is going to be 5. So basically, those will be your answers. But like I said, for radicals, you are also supposed to check your solutions, just like modulus functions. So try the one if it's going to balance there. So we're saying the square root of 1 minus 1 plus a 2, is it really equals to a 1? So the square root of 2 multiplied by 1 is a 2. Then that 2 minus a 1, that 2 minus 1, that is a 1. The square root of a 1 is just a 1. 1 plus 2 is equals to 1. So this is 3. 3 is not equals to a 1. So 1 is not part of the solutions. What about 5? You're supposed to try 5 as well. So the square root of 2 multiplied by 5 here, it's just a 10. A 10 minus a 1. A 10 minus a 1, that is a 9. The square root of a 9, it is a 3. Then plus a 2 is equals to a 5. So basically, we're just going to have a 5. So a 5 is a valid solution. So for this A, only 5 is the answer. So you come to B. So for b, we've got the square root of 2x minus 1 x plus 3 is equals to a 1. Of course, you're supposed to isolate the square root, but like I said, I prefer you take the 1 to the other side. So I'm going to have 2x minus 1 is equals to 1 plus the square root of x plus 3. Then from now, you now square root on both sides. So I'm going to square root this side and also square root on the other side. So the square and the root are going to cancel. I'm going to have 2x minus 1 is equals to, now this one is going to square 1 and it's also going to square this way expression. When I square 1, of course I'm going to have 1. When I square this expression, I'm going to have x plus 3. So now what do we put on the middle? What we're supposed to put on the middle is 2 multiplied by 1 is a 2. That 2 multiplied by this expression, we're going to have 2 root x plus 3. Alright, so this is what we have. Then you're just supposed to now solve these expressions. So what do we do here? Okay, so we've got a 2x. Okay, 2x minus 1 so we've got, okay, so let's just solve it step by step. 2x minus 1 is equals to, we got a 1 and a 3 there. These ones can add. I'm going to have a 4 plus x plus 2 root x plus 3. Then I think from here I can now put the like terms. I'm going to take the x to the other side. When I take the x to the other side, it's going to be negative. It's going to be 2x minus x, which will just give me x. I'm going to take the 4 to the other side. It's going to be negative 4. Negative 4 minus 1 is going to be negative 5. So I'm going to have negative 5 here is equals to 2 root x plus 3. Alright, so when you reach here, you are again supposed to square. That's the funny part. You're going to square again. So it's x minus 5 is equals to 2 x plus 3. Now this square that you're going to do is the one that is now going to help you find the answer. Okay, so we are going to again square this part and also square that part. So this, of course, when you solve that, x is going to be squared, and then 2 multiplied by x is that's 2x. 2x multiplied by negative 5, we're going to have negative 10x. And then when you square negative 5 squared, that is 25. This will be equals to, when I square 2, I'm going to have a 4. When I square this whole thing, the square is going to cancel. So I'm just going to remain with, the root is going to cancel, so I'm just going to remain with x plus 3. And now we've reached the close to our destination. Then now you solve whatever you have. So of course I'm going to have x squared minus 10x plus 25 is equals to 4x plus a 12. Then you put your like terms together. So I'm going to x squared, I'm going to take the 4x to the other side. It's going to be a minus 4. A minus 4 and a negative 10, they'll give me a negative 14x. Then here I've got a 25, here I've got a 12. If I bring the 12 to the other side, it's going to be negative 12. So it's going to be 25 minus 12. That is like a 13. This will be equals to 0. Then I'm going to look for the product, the sum, and the factors. The two numbers that can, when I multiply them, they'll give me 13. But when I add such numbers, they'll give me a negative 14. I think negative 1 and negative 13 are able to do that. So in this case, therefore, we're going to have x minus 1 and x minus 13 is equals to 0. So the values of x for this expression, x is equals to 1, another x value is equals to 13. So basically that is how you solve that. You check your solutions. One, you've seen most of the time it's not giving us any of the correct answers. Probably 13 might, but you have to check your answers. So if you put 1 here, actually that's not even the equation, it's this one. If we put 1 there, what are we going to have? That is like 2 minus 1, the square root of 1 is 1. That is like 4, the square root of 4 is like 2. So 1 is not also going to give us a solution. So 1 is not correct. But if you put a 13 here, of course those are big numbers, but you can try. But 1 is not one of the solutions. There's a high chance that 13 is an answer. Alright, so I think this question and this question, they are the same. Yeah, they are the same. So C, we've solved it as well because it's the same question, unless if I'm not really paying if there's a smallest detail, but I think that's I think they're the same. Then we come to D. Alright, so for D, not very complicated. Like I've told you, I prefer the other one goes on the other side, so I just remain with 1. X minus 2 this side is equals to, this side I'm going to have x minus 5. Then when I take the other one to the other side, I'm going to have this is negative, it's going to be positive this side, positive the square root of 2x minus 11. Alright, when it's like this, then you solve it like the way we were solving the other ones. We're going to solve it the way we were solving the other one. So you're going to square this side and also square this part. Of course, when you square this side, the roots are going to cancel, so x is equals to x minus 2. So I'm going to have x minus 2 is equals to, on the other side I'm supposed to square this and also multiply on the middle. When I square those ones, you realize that these squares are going to cancel in the extremes. So of course, what am I going to have? I'm going to have 2x. Okay, this other extreme I'm going to have x minus 5. On the other side I'm also going to have 2x minus 11. Then what I'm supposed to have now in the middle, alright, it's going to be something bigger. Let me write my 2x a bit far away. So I'm writing 2x minus 11 on the other side as one of the extremes. So 2 multiplied by this expression is going to be 2 root x minus 5. Then that expression again multiplied by 2x minus 11. Alright, so therefore now what am I going to have? I'm going to have 2. Since these two expressions are multiplying in the brackets, they are going to multiply just the way they are multiplying in the brackets. I'm just going to write them under a root. So I'm going to have x minus 5. Then I'm going to have 2x minus 11. Alright, so basically that is what we have. Then from there we're just now supposed to solve and expand our expressions. Alright, so we've got what can we add and what can we subtract. So I'm going x minus 2. This will be equals to, okay, so the extremes, I think the extremes can add up so that we see what we can have. So we've got x and 2x. When they add, we're going to have 3x. Then we've got negative 5 and negative 11. When they add, we're going to have what? Negative what? This is negative 16. Then plus the whole expression 2x minus 5, 2x minus 11. Now the way this expression comes about, you guys know that if I've got 2, it's multiplying by, let's say, the square root of let's say 6, and the other one also has a root. Let's say it's multiplying the other one, maybe let's say x. Okay, let me say 5. You know that every time you're multiplying like this, the 2 is going to be maintained, of course, but what you have in the root is going to multiply. 6 multiplied by 5. So that's what we did on this part. That's just SADS, right? So just go back on SADS, you're going to understand, or you can also watch our videos on SADS. Alright, so when we have this, then what do we then do? Of course, we put again the like terms. This side I've got x, this side I've got 3x. When I take the 3 to the other side, okay, let me start with the numbers first. It's like it's going to give us a negative answer. So if I take the negative 16 to the other side, it's going to be positive 16. That positive 16 minus 2, I'm going to have a 14. So I'm going to have 14. Then if I take the 3x to the other side, it's going to be negative 3x. Negative 3x plus x, I'm going to have negative 2x. This will be equals to 2 the square root of x minus 5, 2x minus 11. Alright, so this is where we reached. This is where we've reached. Now for us to remain with what we have in the bracket, or what we have under a root, I'm going to divide by 2 on both sides. So now allow me to rub on top. Now if I divide with a 2 throughout, so the 2 into 14, that is a 7. The 2 into the negative 2, that is an x. This will be equals to, the 2 and the 2 are going to divide. I'm just now going to remain with the square root of x minus 5, 2x minus 1. Alright, so this is what I have now, and for me now to do the last one, I'm now supposed to square for the last time to remove now the root completely. Alright, so if I square this square, oh, actually this one is just fine. We're just supposed to solve it. So of course I'm supposed to square x, and I'm supposed to square 7. Let me start with x. Negative x squared, that is just x squared. That is one of the extremes. The other extreme is 7 squared. 7 squared is a 49. Then to find us on the middle, 2 multiplied by 7 is 49. 49 multiplied by negative x, 2 multiplied by 7, that is 14. 14 multiplied by x, that is negative 14x. Alright, that is what we have on the other side. The other side, the square and the root are going to cancel. Now we only have this equation, or this expression, so we're just supposed to expand it. So x multiplied by 2x, x multiplied by 2x, we're just going to have 2x squared. And then x multiplied by the negative 11, we're going to have negative 11x. Then negative 5 multiplied by 2x, we're going to have negative 10x. Then we're going to have plus 55. Alright, so this is what we have. Then we just solve now. Okay, so it's just a matter of putting like terms together, then we solve. Okay, so here we've got 11x minus 10x. So I'm going to have x squared minus 14x plus 49 is equals to 2x squared. This is going to give us negative 21x plus 55. Alright, now that we've got this, I'm going to take all the expressions to one side. So this side I'm just going to remain with 0. This will be equals to 2x squared minus x squared. Then I come to the ones with x, negative 21x plus 14x, then a 55 minus a 49. So in this case 0 will be equals to 2x squared minus x, that is just x squared. Then negative 21x plus 14x, that is negative 7x. Then 55 minus 49, 55, that is a 6. Alright, so this is what we have. Then the question would be, what two numbers can we multiply to give us a 6? But when we add such numbers, the sum is negative 7. What are those two numbers? So we've got a negative 1 and a negative 6. So in this case, our answer is x minus 1, x minus 6 should be equals to 0. So in this case, the values of x for this question, it is 1, and another value of x, it is a 6. So you can check for your answers. You've noticed that most of the times 1 is not giving us a solution, but try if 6 is a solution. So basically that is how we solve this question. Then let's solve the last simple question on this tutorial sheet. Alright, so you can also join us for our tuitions. To join your friends, you can inbox us, Novastone Academy, so that you don't get left out. We already solved this tutorial sheet some time back, so basically this is just a revision for those ones who've not attended any of our sessions. Alright, so basically this, let's say we have a square, we've got 1 plus 2, we have another square, x. This is equals to the square root of x plus a 1. Alright, so what are we supposed to do? At least for this one, we're not taking anything to any other side, we can just square, it's fine. So the square and the root are going to cancel for the first expression, as simple as it can be, plus 2 the square root of x. This will be equals to the square and the root are going to cancel x plus 1. Then what do we do for us to now remain with everything? So I'm going to take the 1 to the other side. I'm going to have 2 root x is equals to x, of course. When I take the 1 to the other side, it's going to be a negative 1. Excuse, now a negative 1 is going to add with this 1. We're going to have a 0. So we're just going to have this expression that we have. Now since we are looking for the value of x, I'm going to divide by 2 on both sides. So when I divide by 2, I'm going to have the square root of x is equals to x over 2. Now for me to now remain with my final answer, I'm going to square root again on both sides. So this will be square rooted, and this one I'm going to put squares on both sides. So this, the square and the root are going to cancel. X now will be equals to, this one is going to be x squared, then 2 squared, that is a 4. Alright, so this is the expression that we have. Okay, so you're able to see that this is just a rational function, just like any other rational function. You solve it the way it is. So we have x is equals to x squared, okay, over 4. Alright, just cross multiply. So I'm going to have 4x is equals to x squared. Then put the like terms. So 4x, when I take the x squared to the other side, it will be negative x squared is equals to 0. Then when you reach here, you know what you're supposed to do. You are supposed to factorize out the x. So in this case, I'm going to have x outside. I'm going to have 4 minus x is equals to 0. So therefore, what are the two now solutions? You know what this means. You know that x is equals to 0, and what you have in the bracket, 4 minus x is equals to 0. So in this case, another value of x, so negative x is equals to negative 4. So x is equals to 4. So this last question, the solutions x is equals to 0 and x is equals to 4. Then you check if both of them are valid or one is not valid. So basically this is how you solve this tutorial sheet. We've literally solved from the first question to the last question. So don't forget to like this video and also comment. Thank you, and we're going to see you in other sessions. Those ones who want to join us, please, you can reach out to us anytime.